With this molecule, we're going to look at an issue that some students have with counting the longest chain. Now, the inclination is to just simply start at the left, 1, 2, 3, 4, 5, 6, and go to the right. However, remember that my goal is not to count necessarily straight from left to right or right to left. My goal is actually to find the longest chain of carbon atoms. So what if instead of starting with this carbon, I started up here? Now I can have 1, 2, 3, 4, 5, 6, 7, a little bit longer chain. But also see that I've got this big kind of what looks like a substituent group down here, but is actually part of the main chain of the molecule. And if I start here, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I actually have 9 carbon atoms in this chain. They don't have to be written from left to right. So what we're always looking for is the longest chain of carbon atoms I can make without ever lifting my pen. And for this molecule, it is 9 atoms. Now what I want to do is figure out what my substituent groups are. Remember, I started up here, followed my chain of carbons and went down here. And what I see is that the 2 groups that were not included in that chain of 9 carbon atoms were these 2 groups. So I have 2 substituent groups in this molecule. I have 2 methyl groups in this molecule. And so I'm going to name this, I have a dimethyl as my substituent. Okay. Since I have 9 carbon atoms, it'll be non-ane, for the ane is for the single bonds. Now I have to figure out where those carbon atoms, or where those methyl groups are, which carbon atoms they're located on. And I'm going to go back and I'm going to actually put in my numbers again, making sure that I number the exact same way that I counted that chain of 9 carbon atoms. So I start here with 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then I go back and count the other direction. 1, 2, 3, 4, 5, 6, 7, 8, and 9. If I look at my red numbers, what I see is that I have a substituent group on carbon 3 and carbon 6. I have my 2 methyl groups. If I look at the blue numbering, I see that I have a substituent on carbon 4 and carbon 7. And so I see that this is not going to be the ideal, that the 3, 6 is going to be the preferred name or the preferred locations for those substituent groups. So now I can put 3, 6 dimethyl nonane. Now, especially for situations like this, where it's easy to forget what my side groups are and what my chain is, it's perfectly fine to rewrite problems on paper, mark out what your chain is. If you have a highlighter, you can also go over the chain with a highlighter, and then you can actually see exactly what's included and see exactly what's not included. So you can mark those and remember that those are substituent groups. Especially when you're working on mastering, it's much more easy to solve the problems if you copy down exactly what you see on the screen on a piece of paper, so that you can take advantage of the numbering thing we've done, circling our substituent groups and marking out our longest chain.